Artificial Intelligence Explained Simply. Part 2. Did you know that your smartphone, without your input, makes decisions in just a few seconds? Find out in the video how machine learning and deep learning make this possible behind the scenes. In today's video, we dive deeper and look at how computers actually learn and how they can generate texts and images. We talk about machine learning and deep learning, but don't worry, I'll explain it in a way that everyone can understand. The basic principle of machine learning. Imagine you want to teach a child to distinguish a dog from a cat. You show them many pictures of dogs and cats and explain the differences. After a while, the child can also recognize whether a picture shows another animal or an inanimate object, even if they have never seen that creature before. They can independently distinguish whether it is a living being or an object. This is the advantage of the human brain to transfer stored knowledge to new situations. This is how machine learning works. Instead of programming fixed rules into the computer, we show it many examples. The computer then looks for patterns on its own and creates its own rules, just like the child can distinguish objects from living beings. In traditional programming, we provide the computer with rules and data, and it delivers results. In machine learning, we give it data and the desired outcomes, and it finds the rules, meaning the patterns behind them, by itself. Types of machine learning. There are different ways computers can learn. First, supervised learning. We show the computer examples and the correct answers. For example, pictures of dogs labeled dog. This way, it learns to classify new pictures correctly. Second, unsupervised learning. Here, the computer only receives the data but no solutions. It must find patterns and structures on its own. This is like when you have to sort a pile of different objects without knowing the criteria. Third, reinforcement learning. The computer tries out different actions and receives a reward when it does it correctly. This is how programs that play chess or Go learn. Most practical applications use supervised learning because it is the most reliable. What is deep learning? Deep learning is a special form of machine learning that tries to mimic the way the human brain works. It uses so-called neural networks, which consist of many layers of artificial neurons. Neurons are nerve cells in our brain that receive, process, and transmit electrical signals. This enables communication between the different parts of our nervous system. Deep means that deep learning simply refers to advanced learning. Imagine a neural network like a team of specialists. The first layer can recognize simple patterns, like edges in an image. The next layer combines this information to recognize more complex shapes. Another layer might identify facial features, and the final layer ultimately decides, this is a face. And here we are with the smartphone that recognizes your face in seconds and unlocks your banking app. Now you have a rough idea of how this works behind the scenes. Deep learning has enabled many breakthroughs in recent years because it is particularly good at recognizing complex patterns, whether in images, speech, or other data. And when it comes to speech, we are back to the smartphone that understands your spoken commands. Differences between image and text. Generation. Image and text generation are based on similar principles of machine learning, but there are essential differences. First, databases. Text generation, e.g., ChatGPT. Models like GPT-4 are trained on large collections of text to understand and generate language. Image generation, e.g., DALL-E 3, uses training data from images and their descriptions to learn visual patterns. Second, technology. Text generators primarily rely on transformer models. Image generators often combine transformers with diffusion models to represent visual details accurately. This may sound a bit technical, but it's not too bad. What are transformer and diffusion models? Transformer models like GPT were originally developed for text processing. They use a mechanism called self-attention to understand the context of words in a sentence. They learn to establish relationships between words in a sequence so that it makes sense. Diffusion models carry out the actual image generation and utilize knowledge from the training data. They start with a noisy image and gradually remove the noise until a clear image emerges. In image generation, transformers are often used to convert texts, prompts, into a form that the diffusion model understands. For example, a transformer translates the text "a dog in the park" into a mathematical instruction that the diffusion model uses for image generation. Why does AI need so much data? You may have heard that AI systems require vast amounts of data. But why is that? Imagine you are learning a new language. If you only hear a few sentences, you will hardly understand the grammar rules. The more examples you hear, the better you can recognize the patterns. The same goes for AI systems. To recognize reliable patterns, they need many examples. If a system is supposed to recognize cats, it must see thousands of pictures of cats in different positions, in various lighting, different breeds, and so on. The good news: once trained, an AI system can apply its knowledge to new situations it has never seen before. Just like the child mentioned above, suddenly identifies animals without knowing them. Limits of machine learning. Despite all the advancements, machine learning also has clear limits. First, data dependency. A system can only be as good as the data it was trained on. Biased or faulty training data leads to distorted results. Second, black box problem. Often, it is unclear why a system arrives at a particular decision. This can be problematic, especially in sensitive areas like medicine or justice. Third, over-specialization. AI systems are often trained for a specific task and cannot easily transfer their knowledge to other areas. Fourth, creativity and true understanding. Current AI systems can deliver impressive results, but they do not truly understand what they are doing. They can recognize and imitate patterns very well, but they lack awareness or true understanding. Fifth, hallucination. AI systems can produce false or fabricated results, especially when they operate outside their training context. So, stay tuned and feel free to subscribe to my channel so you don't miss any videos. And of course, I appreciate a thumbs up